So this packet handling capacity of the network is called as MTU, maximum transmission unit. Okay. So if size of the IP exceeds the MTU, then IP datagram gets fragmented into multiple parts. Okay, there is certain rule for fragmentation that we will discuss. Okay. Example is one of the MTU or FDDI network is having MTU 4352, whereas Ethernet is having MTU 1500. So anyway, the packet as it is will not travel in the other network. That's why we need to fragment this. IP router splits the datagram into several datagram. Okay, what is the overhead with this is header gets added with each and every fragmentation. Okay, header gets added with each and every fragmentation. Okay, and fragmentations are reassembled at receiver only. Okay, fragmentations are reassembled at receiver only. So fragmentation can be done by the sender or any in between router. Okay, any in between router. Same fragmentation can happen several times. Okay, we'll see similar example on this so that you can understand what exactly mean by this. And reassembly of original datagram is only at the destination. Means if at all here fragmentation has happened, and after this, if another network comes which is having the MTU 5000, okay, so that it will not get reassembled here. Reassembly is only at the destination. This is the thumb rule. Okay, this is the thumb rule. Then how this fragmentation gets identified at the destination or how to reassemble this? For that, you need some information. Okay, and that is provided by the IP header part. Okay, so which are the fields involved in the fragmentation? Which are the IP header fields involved in the fragmentation? So what you can see is the red marks. Okay, what red fields, that is ID, because ID remains same for all fragmented datagram, so that at the receiving end it will understand. Okay, then total length, because how much is the payload in that, for that total length is very much essential. Then DF, which is a flag which is called as do not fragment. MF is the flag which gives the indication regarding more fragments, and the offset. So once all these fields together will give the information regarding how the data is fragmented and how to reassemble this data. So fragment offset is the offset of the payload of current fragment. Means original data is this. Okay, it is fragmented into several parts, suppose 3. So this is offset 0 for understanding. This is offset 500. This is offset 1000. So while reading the data, it will read this as a fragment 1, this as a fragment 2, this as a fragment 3. So your total 1500 is divided into 0 to 500, 500 to 1000, 1000 to 1500. Okay, like that. So this typical gives the offset value, so that at the reassembly it will rearrange the packet in that order. And total length gives the information regarding current total length, because if at all it is cut here, that is 3 segments are not of equal size, here it becomes 300, like that. So it should be known to other side. When the router receives the datagram, what it will check? So size of the datagram, then MTU of the destination network. Okay, MTU of the destination network. and DF bit value in the IP header. So with the DF bit value, following are the different cases. Means if size is smaller than MTU, no problem. Router transmit the datagram without fragmentation. This is the case one. Straightforward. Okay, straightforward. Then size of the datagram is greater than MTU. Means the same packet cannot travel in that particular network as it is because of size constraint, but DF bit is set. But DF bit is set. In that case, it will discard the datagram. This is the case 2. Because DF will give the indication that do not fragment. DF give the indication that do not fragment. That's why no fragmentation is allowed. But again, MTU is less. That's why no remedy, drop the data. Okay. Case 3 is size of the datagram is greater than MTU and DF bit is set to 0. And the DF bit is set to 0. In this case, the router divide the datagram into fragments less than or equal to MTU. Less than or equal to MTU. Okay. And router attach the IP header. Router attach the IP header with the fragment by changing the fields which we have seen, that is ID remains same, total length will get changed, fragment offset will added, MF will added, and DF is 0. Okay. Then router transmit the fragments to of the datagram. Okay. While doing this, it changes the total length because depending upon the what is the payload size, total length get changed. It sets the MF bit to 1 because more fragments are coming. Only last fragment is 0. Only last fragment is 0. Okay. It sets the offset and recalculate the header checksum. Recalculate the header because header fields are changed. That's why it is very much essential to recalculate the checksum. Got the point? Understood what exactly router is doing if at all MTU is not matching? Okay, now question. If station receives datagram with MF is equal to 0, what are the possibilities? If station receives datagram with MF is equal to 0, what are the possibilities? What the question? Station receives and it will check that MF is equal to 0. What may be the two options? Yes, this is the last fragment, or this is the last fragment, or anybody? Station receives the datagram and if it checks that MF bit is 0, then one option is, who has given Priyanka, last fragmented, yes, very correct, or anybody? Because once we understand this, problems are very easy. MF bit is 0, that means that datagram is either last fragmented or last fragment or not fragmented, original datagram. Got the point? When it checks that MF is equal to 0, either this is last fragment or not fragment. Then how it will resolve that whether it is last fragment or not fragment? How it will resolve that whether it is last fragment or not fragmented datagram? I'll give half mark for ISC. You have received datagram with the MF0, so that there are two options. One is either it is last fragmented datagram or it is not fragmented datagram. Then how it will resolve that whether it is last fragmented or not fragmented? I'll give half minute. It will check the offset. It will check the offset. If offset is not present, then it is not fragmented datagram. If offset is having some value, that means it is last fragmented datagram. Got the point? Clear? Yes. Means on the basis of that, it will resolve whether the packet is fragmented or not. Okay, only MF0 will have dilemma whether it is last fragment or not fragment. Then it will check the offset. If offset is present, that means definitely packet has fragmented. If offset is not present, that means packet has not fragmented, because there is no case that last fragment having the offset 0. There is no case that last fragment having the offset 0. Yutesh. Okay, got the point. Now we'll solve problems so that you can understand the things. Host A in the network X with the MTU 520, host B with the MTU 200 bytes, and A want to send the packet to B. A want to send the packet to B. Now router receives the datagram with these fields. Okay, header length, take this, because last time I asked sit with the pen and paper. Sit with the pen and paper. That's why you can able to solve this very easily. Header length is 20. Payload is 500. So that total length is 520. DF bit is 0. DF bit is 0. Okay, so when it receives at the router, it will check that MTU is 200. It will check that MTU is 200 and DF bit is 0. That means allowed to fragment. Now we need to calculate how this 520 byte total length datagram gets forwarded into 200 MTU network. How this 520 byte total size datagram forwarded to 200 MTU network, because it will not travel as it is. We need to slice this into smaller parts, and that is called as fragmentation. So MTU is 200. MT is 200. So maximum length allowed in the network is 200. Out of that, 20 byte will be the header. So remaining is 180. Now you need to find what is the maximum data can be accommodated in this particular network, which is divisible by 8. Which is divisible by 8. So that we can put the offset value. So that we can put the offset value. So what number? Divide 180 by 8. Or 22. 22 is coming. So 22 into 8. 22 into 8. What is that number? 176. Yes. So 176 is the payload and 20 is the header. So total 9, 126 will carry in the network. So we'll calculate other fields. So we'll calculate other field. 126 byte is the data in the first, 176 is the data in the second, remaining data in the third. Because total data is 500. Total data is 500. So data will be fragmented into 3 parts. Okay, data is fragmented into 3 parts. 176 is the maximum size and remaining in the third. If payload size is 490, then this will be 138. So remaining all data will be accommodated in the third fragment. Okay, so calculate the fields. So header length is 20. Header length is, or field value is interesting. Field value is 5. Total length is 20. Okay. Total length is this plus header 196. MF bit is set. For first, offset value is 0. For the second, header length is 20. This MF bit is set. Offset value is 22. Okay, for the third, total length is 168. Offset is 144. MF is 0 because it is the last fragment. So see the tables. See the tables so that you can understand it very easily. So at the destination, it will arrange the packet on the basis of offset. So first packet is offset 0, second packet is offset 22, third packet is offset 44. So immediately what you can see is MF11, so last fragment is 0 and total length is this. Clear? Same problems you can search it, see on your Moodle or Google Classroom, both places is available. I'll put the PDF for solved problems. In the class, we'll solve 2 or 3. On the Moodle or Google Classroom, you can check more problems. Some are solved, some are unsolved. Okay, some are solved, some are unsolved. So you can solve on your own. What the point? Okay. Any doubt? Now, what is the formula for overheads in the fragmentation? Can you calculate the generic formula for overheads in the calculation? So if fragments are n, yes, very good. If fragments are n, n minus 1 into header size is the overhead. If 3 fragments, 2 into 20, 40 is the overhead. If 3 fragments, 3 into or 4 into, depending upon number of fragments, minus 1 into header size. Oh, it is size. Is the overhead in the fragmentation. So if I calculate the total length, how it will come? It will come to be, instead of 520, it is 560. It is 560. Okay, that is the overhead. But again, as the packets are easily passed through the network, this is tolerable, is acceptable. We'll move ahead. Now you solve this. I'll give 5 minutes. Immediately I'll show you the answer. IP datagram with the ID this 111 with the total size 3400. Total size 3400. Header size 20. Passing through MTU 4000 to 1200. Find the fields ID remains same, header size remains same, total length, DF remains same, MF and offset. So first you calculate how many fragments. So total size is 3400 and MT is 1200. That's why maximum 3 fragments. You can easily calculate that by simple division. 3 fragments. Then secondly, what is the size of the payload? What is the size of the payload? What is the size of the payload? Okay. Then if we move ahead, I'll give you 2 minutes so that you can easily calculate the fields at least for one fragment. Then I will show you the results. Because after this, you're not that obedient so that you can solve it on offline. But at the time of lecture only, you have some time so that you can solve it. No need of calculator, nothing is required. Very easy calculations. Very easy calculations. So make the table which contains header size, total length, ID, DF, MF and offset. and just put the values. And just put the values. New slide is visible? New slide with answer is visible? Yes, okay. So maximum payload accommodation is 1176. 1176 because 1200 minus 20 is 1180. The number which is divisible by 8 is 1196. Is 1196. So 0 to 1196 is the fragment 1. 0 to 1195. 1196 to another is the fragment 2, and remaining is the fragment 3. Remaining data is the fragment 3. So that byte offset is 0. 1196 divided by 8 is 147. So offset for the fragment 2 is 147. Offset for the fragment 3 is 294. The change is MF bit set to 0 because this is the last fragment. MF bit set to 0 is the last fragment. 1176 divided by 8. Because 1196 is the total size, minus 20 is 1176. Jitesh, got the point? But what? Jitesh, you can speak? Jitesh, you're unmute.
Am I audible?
Yes, yes.
Sir, in total length, it is included header size also?
Yes, yes.
1196?
Total length is payload plus header.
Okay, sir.
That's why.
Actually, I'm having doubt in that.
Yes, yes, yes. Yes, clear for everybody? Because as this is the objective type question, you must able to solve it very fast. I will give the blank spaces where you have to put the numbers. That is a minimum one question. So one number will give you 1 mark. So this problem you can have at least 2 or 3 marks where you can put just numbers. Okay, multiple choice type. Example can be added. So try to solve it within no time so that all the calculations, there is no need of calculator or something. Just divide the number and get the values. Okay, we'll conduct mock test, no problem. For numericals, very easy numericals are there. I think in the ISA also you have solved two or three. Very simple. That if baud rate is this, what is the bit rate, or if bit rate is this, what is the baud rate, like that, or channel capacity kind of thing. So once you know the formula, just put the values. This kind of numericals are there. No very complex numericals like DSP or signals and system. There are numericals on the timers that is in the next module, but here very simple numericals are there. You can check the Moodle and also the Google Classroom for the problems in the performance of protocol, problems in the very first module regarding the channel bandwidth and other, and this third module regarding the IPs. Okay, I'll put it today or tomorrow. No problem. Now, next problem already discussed. Only thing for your practice you can solve. Total length is 2400. Header is 20. MTU is 1000. MTU is 1000. That's why what you can see is 996 is the number coming. Total size. So payload size is 976. So when it is divided by 8, it comes out to be 122. So in the first 976, in the second also 976, remaining data in the third. Offset is 0, 122, 244. MF is 0, sorry, MF is 1, 1, 0. I'll show you the answers. So this is the first fragment. This is the first fragment. This is the second fragment. So change is here. Offset becomes 122. MF is 1. Everything remains same. So remaining data will be accommodated in the third fragment. Remaining data will be accommodated in third fragment. 996, 1000 is the MTU. 1000 is the MTU. So to calculate it, 1000 minus 20 is 980. Find out the maximum number divisible by 8. Arthi, got the point? 980 is not fully divisible by 8. So you have to find out the number, maximum number, which is divisible by 8. So that comes out to be 976. Because I need offset as a whole number. I cannot put it 122.4 or 122.5 or 122.2 like that. Okay, now we'll make this more complex. We'll make this more complex because idea is more fragments are possible. Means if at all further this MTU comes out to be 500 and this particular packet is entering in that network. This particular packet is entering into that network so that packet 1 is anyway going through the network, packet 2 is going into the other network where MTU is less than this, so it will get further fragmented. It will get further fragmented. Okay, so that how it will be get received at the destination is the interesting part. Okay, is the interesting part. We'll see another example. So here what you can see is first packet with 1400. So what may be the MTU of this network? Anybody? If I say header is 20, which is default there. You can put it in the chat box. So it is going from 5000 MTU to because it is fragmented with 1400 as a data size. So what will be the MTU of this network where this data gets fragmented into multiple parts? So this is the payload. This is the payload. Got the point? Or you can say greater than this. Greater than this. So here exactly 1400 is divisible by 8. That's why what is the previous problem that 996, 976 instead of 980 we have to take 976. Here 1400 as it is you can take. So divisible by 8 is 175, divisible by 8 is 350. So offsets are this 0, 175, 350. Now if second packet enters into the another network where MTU is less, will make this problem complex. Up to this point clear? I think no much complex calculations are there, very simple. Only conceptual understanding is essential. Up to this point clear? So that I will show you another screen which is bit complex. Now on this screen what you can see is second datagram is get further fragmented. Is get further fragmented, which is having the MTU is 820. And this size is 1420. This size is 1420. Now change is This is the first fragment. So offset remains of original datagram. Offset remains of original datagram. What beautiful thing you can see here is what must be the MF of this? Anybody? Ishika?
Or maybe one.
MF, this datagram further fragmented here. So this is the first fragment, this is the last fragment. So what should be the MF for this? Yutesh,
So
Vinash,
800.
MF is either 0 or 1.
Oh,
Yes. How come it is 1?
one. It is not the last packet. That's why.
But how the router will come to know that this is the last fragment?
Uh,
Because it has received a datagram and is further fragmented into 2.